Hello everyone, welcome to the Mathematics MY channel. In this video, we are going to solve this interesting infinite sum. So, how to begin? Well, first I'm going to write this infinite series by using sigma notation. So, we can write sum of n is equal 0 to infinity. Then first term here 1 over 1, 1 over 2, then 1 over 3. So, we know general term 1 over n plus 1, then here 1 5 9, so we know 4n plus 1, so 4 times n plus 1 over then here 2 plus 2 we know, this part 2 plus 2 we know 4, then 6 plus 6 we know 12, then 10 plus 10 we know 20, so we can represent that series 8 times n plus 4. Then here 3 plus 3 we know 6, 7 plus 7 we know 14, so we know this is equal to 8 times n plus 6 over 4 8 12 we know 4n plus 4. Then here last term 1 over 2, 1 over 3, 1 over 4, so 1 over n plus 2. Well, then we can simplify. Now we know this is equal to sum of n is equal 0 to infinity. Here 1 over n plus 1, then here 4n plus 1 over 8 times n plus 4 we know 4 is a common factor, so 2n plus 1, then here 4n plus 4, so 4 times n plus 1 over then 8 times n plus 6, we can take 2 as a common factor, so 4 times n plus 3, then here last term 1 over n plus 2. Well, now we know this n plus 1 get cancelled, this 4 again get cancelled, so we have 1 over 2 sum of n is equal 0 to infinity. In the numerator we have 4 times n plus 1 over in the denominator 2n plus 1, 4 times n plus 3, and here n plus 2. Okay. What's the next step? Well, now I'm going to take the partial fraction decomposition. So here 1/2 n is equal 0 to infinity. Now I'm going to use a trick. So here now I'm going to take 4n plus 3 and n plus 2 together. So here 4n plus 3 n plus 2, we know this parenthesis will be 0 when n is equal to minus 3 over 4. So if we plug in minus 3 over 4 here in the numerator, we know minus 2 and minus 1/2, so minus 1/2, then plus here now I'm going to take 2n plus 1 times n plus 2 together, then we should substitute where n is equal minus 1/2, so here we have minus 1 and here we have 1. Well, now we can write this is equal to here minus sign, here minus sign will be plus, so 4, but here 2, so we have 2 times sum of n is equal 0 to infinity 1 over 4 times n plus 3 n plus 2, then for this sum here minus 1/2 infinite sum n is equal 0 to infinity 1 over 2n plus 1 times n plus 2. Then as a next step, here I'm going to take this 4 as a common factor. So here we know 1 over 2 sum of 0 to infinity. Now here we have 1 over n plus 3 over 4 n plus 2. Then minus, here I'm going to take 2 as a common factor. So 1 over 2, sorry, here 2, so 1 over 4, 1 over 4, infinite sum, n is equal 0 to infinity, 1 over n plus 1 half n plus 2. Okay, then again I'm going to take the partial fraction. So here 1 half sum of n is equal 0 to infinity 1 over so here I'm going to write n plus 3 over 4. So we should plug in minus 3 over 4 for this n. So we have here 4 over 5, 5 over 4. So in the numerator we can write 4 over 5. Then here we have minus 4 over 5 n plus 2, n plus 2. Okay, then here we have minus 1 over 4, minus 1 over 4, sum of n is equal 0 to infinity. Now if we find the partial fractions, here we have minus 1 half to minus 1 half, so 3 over 2, so 2 over 3, 2 over 3 n plus 1 half, and here also 2 over 3 n plus 2. Well, then we know this 4 over 5 we can take as a common factor. So 4 over 5, 4, 2 get cancelled. So we have 2 over 5 sum of n is equal 0 to infinity 1 over n plus 3 over 4 minus 1 over n plus 2. Then here if we take 2 over 3 as a common factor, we have 1 over 6 sum of n is equal 0 to infinity. Here we have 1 over n plus 1 half minus 1 over n plus 2. Well, now I think you know about the digamma function, series representation of digamma function. So you can watch my digamma function videos. Well, then we know this infinite series we can represent by using digamma function. Here digamma of 2 minus digamma of 3 over 4. Then here minus 1 over 6 digamma of 2 minus digamma of 1 half. Okay, here 2 over 5 digamma of 2 is equal to 1 minus gamma. We found the value of digamma of 2 in previous videos, and here minus digamma of 3 over 4. So we know digamma of 1 minus x is equal to digamma of x plus pi times cotangent of 5x. So if we plug in 1 over 4, so 1 minus 1 over 4 we know 3 over 4 is equal to digamma of 1 over 4 plus pi. Then here digamma of 1 over 4, so I'm going to use the special value of digamma of 1 over 4 minus pi over 2 minus 3 times natural log of 2 minus gamma, and here we have pi. So if we simplify, we have pi over 2 minus 3 times natural log of 2 minus gamma. So we have here pi over 2 plus 3 times natural log of 2 plus gamma. Okay, then here minus 1 over 6. Now digamma of 2, again we know 1 minus gamma minus diagonal of 1/2. So in the previous video I also evaluate the value of diagonal of 1/2. We know diagonal of 1/2 is equal to minus gamma minus 2 times natural log of 2. So here we have plus gamma plus 2 times natural log of 2. Now we can simplify here. Gamma Euler's-Mascheroni constant get cancelled. So we have here 2/5 minus 2 get cancelled. So pi over 5 plus 6/5 times natural log of 2 minus 1/6 then minus 1/3 natural log of 2. Well, now we can simplify. So we have 7/30 minus 5/5 plus here 13/15 natural log of 2. Well, this is the answer for this interesting sum. If you like this type of videos, please subscribe this channel. Thank you for watching.